All right, good afternoon. Happy Monday. Okay, so tomorrow we're going to take an exam at 8, 15-1, 15-2. So I want to take any questions you might have on that first. Anybody have any problems or questions on 15-1, 15-2? It's only 10 questions. So I kept the number of questions down on this. And then the other day, I gave you a bunch of properties of logarithms, and that was lesson 16-1. So I was going to see where we're at and possibly teach 16-2 today, which is solving logarithmic functions. But do we have any questions on anything up to this point? The exam for tomorrow or lesson 16-1? No questions on 16-1?
No, I don't think so.
All right. All right, well, let's take a look at 16-2. It may not take the entire period. And if we have extra time, I'll give it to you to study for the exam for tomorrow in your teams. But let's look at 16-2. Okay. 16-2 is solving exponential equations. Now notice this does not say logarithmic, it says exponential. So we will solve logarithmic equations, but when you see these problems, they're going to be exponential equations. And then after this, we'll solve logarithmic equations. All right, so this is California Common Core Standard F-LE 0.4.2. And I would do the Explorer. So we're going to be solving exponential equations. This first thing we're going to look at is solving it graphically. So this means on the calculator, that graphical approach. So for example, if you had a nasty problem like 275e to the 0.06x, I mean, right away you're thinking this is going to be hard to do by hand. And they're asking you to solve it. What you're going to do is under y sub 1 in the equation editor, you're going to put 275e to the 0.06x. And under y sub 2, you're going to put that horizontal line y equals 1000 and set up your window to capture a point of intersection. So once again, you're going to find a point of intersection by using the intersect feature. And then you're going to, the x, this is going to be 1000. The x value is going to be the solution to this exponential equation. All right. So go ahead and set up your window. Remember, this is an exponential growth function. And this is a horizontal line through 1000. You're trying to capture the point of intersection, and you're going to have to define your window properly to do that. After you get your window, you're going to go second trace and use the intersect feature. So go ahead and tell me your point of intersection when you get it.
I got 21.516,403.
That's correct, 21.5164. So basically, depending on how they want you to round, you would say 21.5 or 21.52. So however they want you to round. All right, so this is in the Explorer. This is solving exponential equations using the graphical approach. Does anybody want to ask me about this problem? I'm not going to work another one.
Yes, I have a question. How you find out what the x value is again?
On the calculator, you go to second trace. So second trace up here, which is second calc, and you're going to pick the intersect feature.
Okay. Thank you.
And the point of intersection, the x value is going to be the solution.
Okay, thank you.
Okay, anybody have a question about the window, or was everybody able to come up with this point of intersection?
What window did you use?
Okay, somebody who had a good window, what did you have?
My window was, my x min was 0, my x max was 100, and then the x scale was 1, the y minimum was 0, and the y max was 1,200. 1,000.
Your y min was 0 and your y max was what?
1,200.
And then your y scale was
1.
So there isn't a right or wrong answer for that. You've got to come up with the window setting to capture the point of intersection. So one thing you know for sure, that this is a horizontal line, so you have to capture 1,000. So you can go from 500 to 1,500, but you got to capture 1,000. So you have to have something lower and higher to capture that horizontal line. All right, anybody want to ask me more questions about that, like the window and stuff? Okay, so this is, once again, this is solving exponential equations using a graphical approach. The first objective here is we're solving algebraically. So that's the lesson. All right, so there's two ways to solve these. And so when you see me do these examples, I'm going to do them both ways, and you have to decide which way you like.
Shift your camera a little more to the second board, please.
Okay, the first way is going to be rewriting in logarithmic form. Now, what is logarithmic form? That's the definition I gave you as a logarithm. So I gave you logarithmic form and exponential form and a definition at the very beginning of these logarithms. The second way to solve these is it's called the property of equality. For logarithmic equations. And this is what it says, and it should look familiar to you. I've never given this to you, but there's one that looks like it. It's log base b of x is equal to log base b of y. Now, if you have two logarithms with the same base that are equated, the rule says that you can drop off the logs and say x is equal to y. So that's the property of equality. Now, the one you saw before was b to the x equals b to the y. And I was saying that if you can get the bases of an exponent to be the same, you can drop them off and say x is equal to y. So that's the one you saw before. So this is the one we're dealing with now. So this is for positive numbers. X, Y, and B. And B, by the way, cannot be 1. So not only does the base have to be positive, it can't be 1. All right. So it'll say solve the equation. Solve means find the variable. And it'll say give the exact solution and the approximate solution to 3 decimal places. So they want 2 answers. They want an exact solution and they want an approximate solution, rounded to 3 decimal places. So here's the first problem. And I'm going to call this method 1. Now remember that what I'm going to show you are both algebraic approaches. They're just different approaches. So in this approach, what we're going to do is we're going to simplify this as much as we can. So we're going to divide by 5, divide by 5. And now what we're going to do is we're going to take a natural log to both sides.
Miss Birch, can you move your camera up a little bit, please?
Is that okay?
Yeah, thank you.
So I'm going to take a natural log to both sides. And the reason why I'm doing that is because this is a log base e of e, which is going to get that variable down. So the problem is we're trying to solve for x, but our x is in an exponent. So we got to get him down from there. So now what I created was I created log base e of e, which causes him to come down by that property, that inverse property that I gave you last time. Remember, log base e of e is the power. You guys remember that?
Yes.
So this just stays the natural log of 2. And now we divide by 4. and we get x is equal to the natural log of 2 divided by 4, that's an exact answer. So we would want to circle that because that's exact. And if we want an approximation, we'd put it in the calculator. So what would this be in the calculator?
I got 0.17328679951.
Uh-huh. And they told us to round to the 3, so it's 0.173. So this is your exact answer, and this is your approximation. And now we're going to do it a different way. I'm going to call this method 2. So we're going to do the same exact problem a different way. So notice it's the same exact problem. And we're going to simplify it. So divide by 5, divide by 5. All right, now what we're going to do is we're going to what? We're going to write it in logarithmic form. So this method was taking a natural log to both sides. And now we're going to take an exponential equation and write it in logarithmic form. So how would you write this in logarithmic form? Well, for sure, it's going to be a natural log of what? So look at your notes, and it's the definition of a logarithm. How do you write an exponential form into logarithmic form? How do you do that?
Would it be up to? And
Uh-huh.
equal to, which would be equal to 4x.
And so we're never going to write it like that because log base E is a natural log. So you're never going to see that ever. And so from there, we solve for x. So the exact answer is natural log of 2 divided by 4, which is what we had over here on the left. And then we would put it in the calculator for an approximation, which is going to turn out to be 0.173. So basically what we did is in this method, we took a natural log to both sides to get them down from there. So we could use log base E of e to the x equals x. Over there, we took an exponential form and wrote it in logarithmic form. Let's do another one. So this problem is 5 to the x minus 4 equals 7. We're going to simplify it. So we're going to add 4 and we get 11. And like we did before, we're going to take a natural log to both sides because actually, it's not going to be a natural log. We're going to take a log base 5 to both sides. And the reason why we're taking a log base 5 to both sides is so we can get that x down from there. So see this? Log base b of b to the x equals x. So we were able to get him down. So this right here is the exact answer. And if they want an approximation, we'd have to use the change of base. So it's going to be log base 10 of 11 divided by log base 10 of 5. And we put that on the calculator. So what do you get? So remember, you cannot put this in a base 10 calculator. So you have to use the change of base so that you get log base 10 divided by log base 10. So it changes from 1 log to 2 logs. Tell me what you got.
1.489.
1.490 because you have to round 3 decimal places. Right? Yes? Did you get the rounding or no?
Yeah, I got it.
Okay. By the way, when I listed the methods, I switched them. So when I wrote 1 and 2, that's not method 1 and 2. I switched them accidentally. So this right here is taking a logarithm to both sides. Okay, what we're going to do now is we're going to take the same exact problem. We're going to simplify it, and we're going to change the exponential form to logarithmic form. So here we go. So you add 4 to both sides. And now, how do you write this in logarithmic form? Log base what?
11
Log base.
equals log base 11, 5 equals x, log base of 5. Never mind, I don't.
You're okay. How about log base 5?
Log base 5 of 7 equal to x?
No.
Of 11, I'm sorry.
Okay, let me explain what, maybe it'll help explain what's going on here. You have an x as an exponent. You got to get him down from there. And the way we're getting him down from there is is writing it in logarithmic form. So normally we don't like to do that, but writing it in logarithmic form is getting him down from there. So by writing it in logarithmic form, we're able to write x equals. So you need to look at the definition of exponential form and see how it translates to logarithmic form. So this right here is the answer. That's the exact answer. And the approximation, you would have to use the change of base. So it'd be log base 10 of 11 divided by log base 10 of 5. But we're going to get the same answer over here, 1.490. So it doesn't matter how you'd want to do it. It seems like that way's easier, but it's hard for people to remember the definition. So either way. Anybody want to ask me a question about either method?
So you
I'm
said
just-
we wrote it wrong, right? That method 1 is actually the property of equality?
All right. Number 1 is the property of equality. And number 2 is rewriting it in logarithmic form.
Okay, yeah.
If you're matching up the 2 ways I wrote to solve it and these methods that I'm writing up here. So in one case, I'm taking a logarithm to both sides. In the other case, I'm taking exponential form and writing it in logarithmic form so that I can get the x down from there. All right, last problem. Whenever you see e, you're going to use a natural logarithm. So you got to simplify this down before you do anything. So subtract 5. So if you subtract 5, you get 75. Divide by 2. All right, now, what you're going to do is you're going to take a natural log to both sides. Why are you taking a natural log to both sides?
You get the x down?
Right, exactly. So remember what this means. This means log base e of e. So log base e of e, who gets to come down?
X minus 1.
X minus 1.
So now when we add 1, we get the natural log of 75 over 2 plus 1, and that is the exact answer. There's nothing more you can do to it. You definitely can't add 1 to that. That's not a 1. That's inside the logarithm. That's outside the logarithm. So now to get the approximation, you're going to take the natural log of 75 divided by 2 in parentheses, hit enter and add 1 and tell me what you get.
4.6243.
4.6243. And I think you're supposed to round 3 decimal places, so that 3 shouldn't be there. Now remember the other method. The other method, we're going to simplify it down. So we get 2e to the x minus 1 equals 75. Divide by 2. And now we're going to take the exponential function and write it in logarithmic form. So it's going to be log base e, right? Of what? Look at your definition of a logarithm. This is exponential form. How do you write it in logarithmic form? Log base e of what?
75 over 2 equal to x minus.
Equals x minus 1. So when you add 1, you get exactly what we did on the left, right? Right here. So that's the exact answer. And the approximation would be 4.624. Any questions? Okay, any questions about any of the methods? All right, let's do a couple of word problems, and this will be it for that. Now, obviously, we're going to solve logarithmic equations. Right now, we're just solving exponential equations. So we will solve logarithmic equations. We're not doing that yet, though. So this is the second objective. We're going to solve real world problems. So real world problems by solving an exponential equation. All right, can you guys look on page 805? I'm sorry, page 802. So 802, example A. No, it's just an example. Okay, it's just an example on page 802. Let's read it. I'm going to write down information as we go along. So it says, suppose that 250, well, first let me write down the equation. A equals P. And notice these are all capital letters. P times the quantity 1 plus, what is it? 1 over R over 4 to the n. Okay, so it says, suppose $250 was deposited. Okay, that's your principal. Principal is always what you put into the bank. All right. It says into account that pays 4.5%. So that's your rate, 4.5%. And as a decimal, it'd be 0.045. So don't put 0.4. Remember, you have to move the decimal twice. 4.5% compounded quarterly. The equation that gives the amount A in the account after n quarters for an initial investment P that earns interest at a rate R. Solve for n. So n is the question mark, and we're still looking for what A is. So it says solve for n to find out how long it will take the account to contain. So that's $500. So what you have here is you have A being $500. The principal is $250. This is 1 plus 0.045 divided by 4. And what we have here is we have an exponential equation that we have to solve. In other words, get the n down. So the first thing you want to do is simplify this. So divide by 250. So if you divide by 250, you get a 2, get 1 plus 0.045 divided by 4 to the n power. All right, now we're going to add this thing. So, and you probably want to do this on a calculator. So take 0.045 divided by 4 and add 1. So what's 0.045 divided by 4 and add 1? What do you get?
You get 1.01125.
That's correct. And don't be rounding too much. And so now that we have that simplified down, we can do one of the methods that I just taught you. So I'm just going to take a log to both sides. So if I take a log base 10 to both sides, I get log base 10 of 2 is equal to log base 10 of 1.01125. And do you guys see what I can do here? Can I use the power property? So now that I have a logarithm there, can I use the power property to get them down? Yes, I can. So now what happens? I can solve for n by dividing both sides by this crazy thing. So my n is approximately equal to this, right? So on your calculator, what's log base 10 of 2 divided by log base 10 of 1.01125?
I got 61.9590.
61.96 about. That's right. So what does that mean? So it means that it will take about 61.96 quarters. So when they talk about quarters, they're talking about quarters of a year. So that means every 4 months, or about 15.5 years for the account to contain at least $500. So it will take about 61.96 quarters, or about 15.5 years for the account to contain at least $500. Now, does anybody have any questions about any of these steps? So what I did right here, I used the power property. To get the n down. Okay, one more problem, we're done. Any questions about this one? Okay, this next problem's on page 803. Number 6. Okay, it says, how long will it take to triple a 250 initial investment if an account that pays 4.5% is compounded quarterly. So we're going to use the same formula, A equals P, the principal, times 1 plus R, the rate over 4 to the n power. We're going to write down the variables again. The principal again is $250. This time A is 3 times P because it's tripled.
Move your camera a little bit, please.
And that's going to be, what's 350? I'm sorry, what's 3 times 250?
750.
750. And the rate again is 0.045. So now A is 750. The principal is still 250. And this is going to be 1 plus 0.045 over 4. And once again, we're finding n. So when you divide by 250 this time, you get 3. And this thing is the same number. It's 1.01125 to the n. And I'm going to get them down like I did last time. I'm going to take a log base 10 to both sides. So when I take a log base 10 to both sides, I'm going to use the power property to get them down. And then just like you saw me do last time, to solve for n, I'm going to divide by this crazy thing. Both sides. So that cancels because it's part of a product. And we get n is approximately equal to, okay, now on the calculator, what's log base 10 of 3 divided by log base 10 of 1.01125?
$98.2.
Yep. 98.2. So when we write our answer, we're going to say it will take about 98.2 years, a long time. It will take about 90, oh, I'm sorry, not years, it's quarters. 98.2 quarters. Or about, if you converted that to years, that's about 24.6 years to triple a $250 investment. Now, what this means, you guys, is that if you deposit $250 in the bank, this is saying that it's going to take about 24 years for the initial principal that you put in to triple. Because when you put money in the bank, you earn money for letting the bank borrow your money. So in this problem, the rate you're getting is about 4.5%. And they're saying that it'll take about 25 years for your investment to triple what you put in originally. All right, that is the lesson. I have not posted it yet, but I'll just tell you if you want to know, we're going to do problems 1 through 20, but we're not doing 14, 15, or 16. I do have it created. I just haven't posted because I wasn't sure if I get through the lesson. I wasn't sure if there were going to be a bunch of questions about the exam. So once again, this is lesson 16.2. You're going to do problems 1 through 20, but not 14, 15, or 16. And I will post it when I get a chance. Don't forget the exam tomorrow. on 15.1, 15.2. And what I'd like you to do now, it's 1:35. Class is over at 2:10. We got some time. I want you to go into your Math Wizard teams and work the online evaluate problems in studying for the exam. So in other words, you're going to do problems out of 15.1, 15.2. I will tell you this, there's only 10 questions, and there's 6 questions out of 15.1 and 4 questions out of 15.2. All right. All right, so please, somebody share your screen for the evaluate. And let's see, this is, yeah. So we're going to report back today just in case there are any questions for the class. Let's report back at 2:05. So report back here at 2:05, and I will see you in your Math Wizard teams. All right, guys, sorry I'm late getting back. All right, I just want to check in with you. Anyone want to ask me any questions about anything, or anybody want me to work any problems? Let me say this, okay? Gonna give you a tip here. Problem, okay, lesson 15.1, number 1. I'm on page 754. There is a problem like this on the exam. And in this particular problem, they have log base 2 of x. Well, you can't put that on the calculator. So how do you find these values?
Would you set
Well,
that to log base 10 and then divide?
what's that?
Would you set it to log base 10 and then divide?
Or you could plug in the x values into the logarithmic one and solve algebraically.
If you plug in the values, how are you putting them? Yeah, you could do it algebraically, but the thing is look at this. Here's what I would do. I would put in log base 2 of 1 and look at the graphs. Because log base 2 of 1 is 0. Well, all the graphs say 1, 0. But then when you look at log base 2 of 2 to the 1 is 1. So there's only one graph that has this. So I would just copy down the other points because we don't care about them anyway. You know what I mean? So I'm just telling you, you can do that. So figure out these two, look at the graph, and then copy the other points. Like one of them is 0.25. Who cares what that is? You know, just put it in there. If you wanted to figure it out, log base 2 of 0.25 is log base 2 of 25 hundredths, which is log base 2 of 1/4, which is log base 2 of 4 to the negative 1, which is log base 2 of 2 squared to the negative 1, which is log base 2 of 2 to the negative 2. So this equals -2, but you see what I'm saying? It's a lot of work, and I'm not trying to get you to do this right now. If I were writing the test, I wouldn't even put these values. I would just put those values. So just cheat and look at the graph and pick off the points to fill in the table. Okay, because this is a base 2. If it's base 4, you can't put it in the calculator, right? Okay, is there anything else you want to ask me about? All right. Well, other than this one, this kind of bothered me because it was forcing you to do this table, but the other problems look okay to me. So good luck with the exam. Don't forget it tomorrow morning at 8. Yeah, good luck, okay? And make sure you work as many problems as you need to work. All right, you guys, have a good day, okay? Have a good day.
Bye, Miss Birch.
Bye, guys. Bye, Danielle. Have a good day, hon.